Good? Awesome. Yeah, I heard one person like super enthusiastic. I love that. It's like, what, 10:50? Awesome. So my name is Sage. I am sort of a mix. My development focus is all over the place. I used to be a Microsoft technical evangelist. So I worked with a lot of emerging technologies. And back then, I went through the Windows 7, Windows 8 eras. Windows app development as we moved to Windows 10. And then going on from there, I started to look at conversation as a platform, blockchain as a service, and sort of these emerging technologies that are 10 years out going to become very normalized and very much a part of our everyday lives. So I was at Microsoft for quite a while. I left in January and initially intended to actually launch a blockchain startup. So when I was at Microsoft, did a lot of work with Solidity and Ethereum on Azure. Azure provides like a blockchain as a service. So you can pretty stress-free spin up clusters and nodes in Ethereum and just develop your blockchain and either in a test environment or in a production environment. So I had experience with that. But I wanted to move away from the sort of centralized, decentralized movement. It felt a little bit odd to be doing a decentralization play from within the seat of someone else's cloud. So I left Microsoft and I joined Lighthouse Labs briefly to start their developer curriculum on blockchain. So we worked together with a bunch of blockchain experts in Toronto to build one of the first boot camps specifically for senior developers to look into moving into a blockchain role. Now, blockchain is still very early. We are super early days. I know it's been around for a few years now, but it's still very, very nascent in terms of sophistication for production. But it's an exciting time to get involved in blockchain because we have an opportunity here to really shape the future and the way this entire sector of development evolves. So I was with Lighthouse for about half a year, built that curriculum. It's now launched and running in a couple cities. And you'll see a piece of that later today. And then I co-founded Crescendo, which has nothing to do with blockchain whatsoever. And part of the reason behind that was I realized, I wanted to start a blockchain company, but I didn't feel that I had the team around me and sort of the R&D time and money to really spend 6 to 10 years actually building a startup that would be sophisticated enough, based on where we are today, to actually tackle the healthcare space with blockchain. That's where I wanted to go, and we'll talk a bit more about that later. So Crescendo is now nothing to do with this presentation, but what it is a chatbot and a training tool for diversity and inclusion within the workplace. So typical diversity training is very, very boring. Who's done diversity training before? And who's loved it? Right. It's awful, and it's been shown that people actually forget everything they learn within 3 days of a training. And in fact, they become worse because they now feel that they've checked the box and they're like, oh, I know about biases, I know about diversity, I can be myself. And then they're their rude selves. So we're creating a more scalable, personalized diversity training tool that goes within Slack and tailors real empathetic content to every individual. So you learn based on who you are, based on your experience with diversity and inclusion, and it's all real stories rather than like scripted, fake scenarios. Anyways, moving on from Crescendo back to the blockchain world. Who here has strong knowledge of the blockchain? Okay, awesome, good. If you are like a blockchain expert, get out. This is not going to be a valuable talk for you. This is really a blockchain crash course for people who are new to it. So we're going to take it slow. We're going to look at a couple of examples using a couple of different frameworks. So actually, in my talk description, I said we'd look at Solidity and JavaScript. And then I discovered this amazing framework called Lotion JS, which is also super nascent. It's like V2 or something, and we're going to use like V0.0.4. But we're going to look at two examples. So the first will be Solidity and JavaScript, where JavaScript is sort of like the front end and not actually driving the blockchain. But then we'll look at Lotion, where you actually build the entire transaction protocol with JavaScript. So we're going to look at what blockchain is, how it actually works, why you should care, and how you as a JavaScript developer can participate in this entire movement. So let's go back to the beginning. Throughout time in development, we've always done things this one way. We've put all of our data, we've put all of our operations onto a server somewhere and had everybody access it in that one place. This is a centralized system. So everything, all the compute, all the data store, it all happens in that one spot, and we trust that that is maintained accurately, secure, that anything that we put in there, anything that we take out, will be the truth. Security has come a long way over the years, but there are still some things that we can't do, and we still see a lack of trust and a lot of vulnerability on the internet because of this system. So blockchain aims to really break it out into a way that we can build trust, we can build consistency into these remote communication tools or these remote architectures. So rather than having all nodes in a system point to one data store, blockchain allows nodes to communicate with each other by all maintaining a set of the same information. So at the core of blockchain, it's actually artificial to say the blockchain. You may have heard that before. The blockchain, there's not one single blockchain. In fact, these are all copies that are identical to one another of that same chain of blocks or chain of transactions. So what we're effectively doing is, rather than having one data store, we empower everybody in the network to be an equal owner or to be an equal participant in what gets added to the chain, in what data is actually stored, and what's validated, and in the data that everybody shares together. So let's walk through this. What's actually in these chains of blocks? So every block contains the information about one unique transaction that happens on the network. So if we're talking about banking, for example, if we're talking about sending funds, which is the one that everyone always starts with, a transaction would be a transfer of value or a transfer of money. We'll talk later about how we move beyond crypto, how we move beyond money, but it's an easy place to start. So every block in a chain contains a discrete transaction. And when you add another transaction, rather than updating that same record like you would in a traditional database, what you do is you add an update to it, to the chain. So block 1 here, we have a second transaction. It could be a repeat of the first one. It could be a reverse of the first one. Either way, we still have them adding consecutively like this. And the real power of adding these blocks in an order like this is every block not only contains a transaction, but also a hash of the block before it. And this is where the immutability of the blockchain comes in. And immutability is the unchangeability, or the inability to go back in and say, actually, this was something else. I now retroactively disagree with what happened here. You can't do that with blockchain, and that's really the power that makes it so secure. So this hash of the block before it gets added to that block, and so what we end up doing over time is we build a mathematical link from block to block that can't be changed. It's a one-way hash here. So what we have is you can traverse the blockchain here and compute whether or not the blocks are actually in the right order and contain the right value. So if I was to say, go in here and say, I refute this, maybe I'm injecting some new data into this block, it would mess up this link and the other link, because the data that was in that block is contained in both of those hashes. So if those links are blocked and don't work mathematically, then we know that that chain has been compromised. And because of the power of everybody owning this together, if one node has a compromised block in their chain, they simply grab it from another node and say, OK, I've got the updated one that everybody has. Clear so far? Cool. So now let's say I want to add a transaction to the chain. Typically a participant in the node would either own a single node or a part of a node, or be a participant in some kind of organization that has access to one of these nodes in the blockchain's network. So I'm going to propose this transaction to my node. And what happens is the node that receives that transaction from the application then proposes it to the rest of the network. And we have to go through what's called a consensus protocol to determine who is going to decide what gets added, and also whether or not it gets added at all. As it spreads throughout the network, all of the nodes, depending on the protocol, can vote whether or not they believe that this transaction should be added to the chain. This is based on what's happened in their previous history. This is based on their relationship with the other node. This is based on many factors, and every blockchain protocol has a different way of doing this. And that's really the competitive advantage between the different blockchain services. So you have to really look at these consensus protocols to look at which one is best for the application that you're trying to build. But once a majority or once consensus is reached, then everybody adds that transaction to their blocks. And the process repeats. So this is how blockchains get added or get continued. And because everybody has the exact same copy, it's very secure. The data is replicated, and everybody's an equal participant in making sure that this network is always up to date. So I touched on the consensus protocol here. There's actually 3 protocols that occur or that are used within the blockchain sort of cycle. So the first is the network protocol, and that determines how do peers communicate with each other. How does the information spread? Do they all have to be connected completely? Can they spread sort of periodically? And how often does that happen? The consensus protocol, which we talked about and we'll go a bit deeper into, how are those decisions made? We'll look at proof of work and proof of stake in a moment. And then finally, the transaction protocol, what makes a transaction itself valid? So before we even look at whether or not everyone agrees, does this meet a certain set of criteria where it is consistent with all the rest of the transactions that are happening? Is it modifying the same data? Is it trying to make the same type of operation, or does it not belong at all in what we're trying to do? So these are 2 of the most popular consensus protocols, proof of work and proof of stake. Who's heard of these before? Cool. So proof of work, what we look at is we try and solve something. So in proof of work consensus, you have a complex mathematical goal that your node has to reach before it can propose and confirm a transaction. So in this case, everybody's basically competing to solve that equation first. And so this is where you see people buying really, really high-powered gaming rigs and filling their basement with these hot computers and servers to try and mine Bitcoin. That's what's happening here. They're trying to push compute power so that they can compute this massive hash and solve it first. And the first person or the first node that solves it wins that Bitcoin or wins that value. And that's what makes the cryptocurrency valuable. So Bitcoin has a nice little system where they've got a finite amount of coins that can never be computed. So the more that you compute, the more value, the more the value goes up because there's less availability or less coins to continue to compute. But this is very expensive. So proof of stake takes a much less costly approach. And instead of trying to solve a complex puzzle that doesn't actually contribute to anything in the network, proof of stake looks at the value of every participant and decides who has contributed the most or who has contributed enough sufficiently that they can own a decision or take over ownership of facilitating the rest of the blockchain continuation. So in this case, they're not competing for the value of the coin. They're actually competing for the cost of the transaction. So we'll see that in a little bit when we look at the Solidity app that we built. Ethereum uses this protocol, and rather than have everybody fight for useless work, with the proof of work, that work doesn't actually go anywhere once that's computed. All it does is say, check mark, you have computed enough that you can now get this value. But in this case, the value is actually directly tied to how much it costs to do that transaction. So stepping back from the technical aspect of it for a moment, decentralization is a really powerful concept. It's been happening periodically through many systems and many non-technical aspects of our world. We've been looking more and more to collaborative decision-making, less hierarchical structures within our organizations, a lot more democracy, pretty much. But this is the first time that we've really been able to do it on the web as well in a way that is not just up to chance. So decentralization plus immutability are what make the blockchain such a compelling concept. Immutability is that unchangeable notion. So the fact that you can't undo something without adding a new transaction. You can't simply go back in and change something like you would in a traditional database. It leads to a lot more clarity. It leads to a lot more traceability, and it opens up the use of blockchain to many different scenarios beyond cryptocurrency. And this ultimately amounts to trust in the digital age like we've never seen before. So everyone's heard of Bitcoin. We talked a little bit about the money aspect, but let's move beyond crypto and into some other applications. Because cryptocurrency is great and all, and I'm still a little bit bitter that I didn't buy Bitcoin, because the first time I heard about it, it was $30, and I was a cheap student, and I said, I can't afford $30. I think I spent it on drinks and pizza instead, which is just a real disappointment. But wait, can anyone beat my earliest Bitcoin value? Was it, yeah? When did you hear about it?
So I started mining it, and it was like 10 cents a coin. And I have a wallet somewhere that I lost for
No. You could have been a millionaire. Wow, you win. That's good. I'm going to tell that story. I'm going to be like, one time I was at a conference and someone really messed up. No. Yeah, I hear all these stories about people throwing away their old computers and just literally wading through garbage dumps in the hopes of finding this old hard drive that they had somewhere because it has their key on it. I'm like, man, you're never going to find that thing. But this is, the trend, and this is the way things go. Things that look silly and stupid, like Banana Coin and Dogecoin and all these things now, we live in this weird age where it's hard to tell which one is going to take off. It's really this virality factor, It's kind of luck of the draw, which one gets picked up by the media, by celebrities, by people who have money, by anyone. No matter what the branding is, no matter even the legitimacy of it sometimes, these things can just take off and become incredibly valuable. But beyond cryptocurrency, Spotify might seem like an unlikely player in the blockchain space. But last year, they acquired a blockchain startup to help them with two things. The first is cryptocurrency. So you can spend money in value exchange on the Spotify platform. I'm still curious to see how they end up doing that. But the second is actually music rights attribution. So maintaining the rights and the copyright of artists who publish on Spotify. This is a huge area, and there's a lot of smart researchers working on this. It's a big problem because it's very difficult to trace, especially when you look at covers, people doing acoustic versions or versions in different styles of other people's music. And people are looking into using blockchain to trace specific digests of music and digests of different artistic media to track the propagation of ideas and the propagation of copyright even as it transforms. So Spotify is one of the best positioned to actually make this difference. I'm not sure if YouTube has also jumped on board this, but I would assume that they have. I'm really curious to see where this goes, because when you start to look at how people are currently being compensated for the things that they publish, there's so much wasted money or lost value that's going elsewhere. Sometimes it's not going to anybody at all or any individual artist at all when it goes to a big company like an iTunes or a Spotify. And when you see that initial idea get diluted over covers, diluted over live versions, that value very rarely makes it back, and that attribution very rarely makes it back to the original artist. So blockchain can be used to solve that. Another interesting example, and one that hits close to home for me, is Medical Chain. This is one of the leaders in telemedicine on the blockchain. So what they do is they use blockchain to digitize medical health records in a way that actually makes it very secure, so that doctors who are remote, who are experts in somebody's area of need, can access their healthcare records without risking the exposure, without risking any unwanted disclosure. And this is poised to change the way that we do healthcare, because right now we have a lot of limitations in terms of the way that we can actually access our healthcare and our medical experts. This one hits close to home for me because my mom had cancer, and when I was leaving Microsoft, this is pretty much what I wanted to build. And when she was going through the hospital system, she had like 6 different doctors who all specialized in different things, and none of them would talk to each other. And so it was on us to go to the hospital, pick up a physical CD with her records on them, take it home, either copy it ourselves or put it in the mail or take it physically to another doctor and hand it to them and watch them as they put it in their machine and like took a screenshot of the image. It's like, how is that any more secure than the internet? You know what I mean? Like the amount of data loss there, or the potential for data loss there, is much riskier and much scarier than just emailing it to somebody at this point. So medical chain is tackling a huge, huge problem here. And by putting these records on the blockchain, not only can patients who are in person really, or who are seeing their doctors in person, they can get access to this healthcare much faster. They can be involved in the decisions that are being made about their healthcare. But people who don't have access to doctors, or people who can't make it in proximity to a specialist in their area, they can really access the global network of healthcare practitioners with something like this. And then the final example that I'll share here, actually, is it the final example? I'm not sure. Supply chain management is a huge, huge opportunity for blockchain. So De Beers is using blockchain to track their diamonds from mine to consumer. So what they do is they're developing a technology that creates, again, some kind of a digest or some kind of a digital representation of every unique diamond, logs it at every step of the way as it moves from the mine to the processing facility to one of the stores to one of the actual, or one of the distributors to one of the stores, and then to the actual consumer. And so when you eventually buy your diamond, you can see, yes, this is a De Beers diamond. Here's the entire path that it took along the way, and verify its existence and its ethicality, I guess, on the blockchain. And supply chain goes beyond like value or high value items, but also to things like organic foods, fish, coffee, things like this, fair trade food, designer handbags, things like that. Anything that can be faked or counterfeit, blockchain provides that sort of extra layer of verification. So I actually have a friend in Toronto who is working on a company right now for supply chain on the blockchain. And they're tracing the manufacturing of ice wines from Canada as it moves overseas to Asia. Because apparently ice wine in Canada is like super coveted and super expensive over there. And what happens is people are taking old bottles, filling it with fake stuff, and selling it at a huge price. So what this company is doing is they're actually using NFC and blockchain to create a tag that goes on top of the bottle. And when the bottle is opened, it logs on the blockchain that has been opened, that's been consumed. And every bottle has a tag that you can scan in an app. So when you go to a store, you can say, hey, has this been opened before? Is this the real deal? And if it is, then you can buy it safely, consume happily, and know that it's all fine and dandy. So these things are happening now. They're working. Yes?
Just to clarify, so supply chain is the type of use case where they follow from where it starts to where it ends?
Yes. Yeah. If anyone didn't hear that, supply chain is the use case that follows a product or a good from where it starts to where it ends. And yeah, when we look at things like, there's people who are looking into doing halal meats and organic meats, even things that are allergen friendly or unfriendly. But the difficulty there comes in human error. There's still always an opportunity for a human to fudge the system in a way. Like if you have to log an organic fruit, for example, like how do we know that that banana is the same banana? How do we know that the person didn't just check the box to get done their day faster or improve their metrics? So surrounding the amazing immutability of the blockchain, there's still other like human elements that we have to account for, and it's up to us to really build those into our systems. How long do I have on this talk, by the way? Because we haven't got to the demo yet. Okay, let's talk about blockchain with JavaScript. So there's two things that I mentioned. We're going to talk about JavaScript as a front end using Solidity and Ethereum, and JavaScript really driving the car with Lotion and Tendermint. So Lotion, well, I'll start with Solidity. Solidity is the language that underlies Ethereum, or that you can use to interact with Ethereum. It's its own language, completely separate. It's used to write smart contracts, and we'll talk about those in a second. Lotion is a super cool framework, and it interacts with the Tendermint protocol, which is Byzantine fault tolerance, again, similar to proof of work. But Tendermint is a really interesting organization because they're working at creating Cosmos, which is sort of blockchain for anybody with any protocols that you want. I highly encourage you to follow that project. So let's talk Ethereum for a moment. Ethereum is based on smart contracts, and this is a super intelligent idea here. It's pretty genius. BlockGeeks is another great resource for learning about blockchain development. They have some good resources for JavaScript developers too, so take a note of that if you're interested in learning more. This example comes from them, and it's how smart contracts can be used to facilitate the transfer of value, but not just monetary value, but actual like physical value as well. So let's say I want to sell my house, and someone here wants to buy my house. What a smart contract, or the things that we need to do in this exchange are match the buyer and the seller. We need to ensure that we receive the assets and that we can distribute them to the next person. This all has to happen online, and it's very difficult with things like houses, but in this case, we'd use like the deed of the house and any of the documentation that confirms ownership. So what happens with the actual smart contract is it grabs all of that information, performs the necessary updates, and it actually can interact with other systems as well, which makes smart contracts very compelling. So rather than have everything on the blockchain, which would be fairly insecure, we can actually have only the data of the smart contracts and the transactions that happen through smart contracts stored on that chain. So the smart contract can just say, node A transferred value of house to node B. This has been confirmed as interacted with all these other parties. So digitizing the land deed can be done through one service. Working through the settlement, ensuring that the ownership is undisputed with the government, with anybody who has to confirm that depending around where they live in the world. And then digitizing that currency that's been transferred as well, and facilitating the transfer from one to the other and vice versa. I see some phones going up, so I'll leave this up for a second. Too much to read, yeah. I highly recommend that you look through the BlockGeeks resources. They're pretty hefty, and so they've got some free resources, and they also have online courses that you can go through too. Super useful. Smart contracts at a deeper level, pretty much what's happening is an option contract is being written between two parties, and this is somewhat standardized. So the contract is pretty much just a script that would run, and then based on what you want it to do, it selects out which actual changes it's going to make. And then it has to be triggered somehow. So every purpose will have a different type of trigger. So it might be an expiration date if we're talking about food, or if we're talking about some kind of an expiring deal. If a strike price is hit, whatever that trigger is, you have to build that into your system as well, and that'll trigger the smart contract to be executed and then added to the chain if it passes. And an interesting sort of side note from this is when you have blockchain systems that are being used widely, regulators can actually now use those to observe trends, because even if it doesn't have access to the exact location of where this house was that was bought and sold, what you get is this high-level data that's anonymized and easy to use to see trends in the market and where things are going. So this is the set of tools that I use to work on Ethereum apps. Solidity is a smart contract language. Truffle is an awesome framework for creating and deploying smart contracts. Ethereum is the actual blockchain technology with the consensus protocol. MetaMask is a browser-based crypto wallet. I personally don't have any cryptocurrency myself, but when we deal with building distributed applications or dApps, it's good to know what it would look like to that end user and to actually prove that the value is being transferred between accounts. And then in order to test it out, I use Ganache, which is also owned by the same folks who made Truffle, which is a personal blockchain development environment. Cool. So let's take a look at that. My screen settings are here. Let me just get rid of that. OK, so this is a demo that I built called Bed and Blockchain. It's pretty much like a decentralized version of an Airbnb. And this is what it looks like. So very simple right now. But the idea is that you can list an item, and you can book it or have other people book it in exchange for Ether. And I mentioned earlier MetaMask. So this is actually pulling information from my MetaMask account, which I have right up here. So you can see I've got 98 Ether, which is like a ridiculous amount of US currency. And this is my current account. So I should also mention, by the way, if you want to access any of this, you're welcome to take a look at it, clone it, fork it, contribute to it. This is an ongoing demo, and this is my GitHub. Also, I've got Bed and Blockchain Start, which is a bit of a tutorial if you want to go through that yourself. So let's take a look at how we set up this environment. And I'm conscious of time, so I'm going to kind of rush through this a little bit. But this is Ganache. And what it does is it sets up a chain for you to use running locally on your own machine. So it's a great testing environment. This is the mnemonic that we use to verify that we're connecting to that same chain. So I've actually uploaded that into MetaMask and created a new MetaMask account on that mnemonic. So it's connecting in here, and that's where we're getting the value of that account. So let me run it. I'll show you the code. Oops, I just opened Postman. Yeah, it's going to be insistent, so I'm going to get rid of it. OK, so this is our app. What we're doing here is we're just loading all of the data in from just like a JSON file right now. It's not a dynamic application. And we are processing things through the smart contract itself. So the smart contract here is called booking.sol. And we've got a couple of different functions that you can execute through this smart contract. So every time we book a property, we execute this smart contract one way or another. This is the main value transfer function here. So what we're doing is we're looking for the actual the listing, sorry, all of the bookings from that booker. We're receiving the value from the actual sender themselves, linking that to their account, and then we're transferring that value to the next the person who listed the contract, the property. I mentioned Truffle earlier. So Truffle has a really nice way of deploying the contracts to the chain. So when you set up your development environment, you just have to write a deployment script like this, which takes your contract and just deploys it to the network. And it has to be deployed to the network because it has to be available for anybody to run. So it gets added to that network. And it's actually worth mentioning that once it's added to the network, anybody can execute it. So anything that you have in there is just free game for anyone to see. So it's not wise to put anything, any private keys in there. You have to really be careful about what data is getting sent and how it can interact with the blockchain. because if you have something there that can sort of override other people's information, and it shouldn't, anybody can access that, and that can be a big point of vulnerability. So one of the issues with blockchains that are based with smart contracts is that you can get malicious nodes who come in and try and overwhelm your network. So consensus protocols are great in that they try and avoid that, but you can still have, in some situations, if it's just a majority that you need to make a decision, you can get a majority of malicious nodes in that network who can then trigger a smart contract to run and then override the consensus and say, yes, this is a valid transaction, and then that can get added to the chain. It's like a very, very small probability that that happens, but it's still a possibility. So that's worth thinking about. We have very little time, so I think I'm going to switch over to the Lotion demo because I think this is a bit more interesting for you as JS devs. So Lotion is based on Tendermint, which again is sort of aiming to make things more secure and I guess easier to use. And Lotion has very, very simple blockchain logic. So I will go into that code here. So like I said before, this is all written in JavaScript. There is no other thing happening. It's using Lotion to spin up a new Tendermint cluster and connect to that and then make things happen. So what you have to do when you're creating a Lotion app is the first thing is to write the initial state of the blockchain. So in this case, what we're building is a decentralized sort of peer-to-peer time-sharing economy. Rather than sharing the value of currency, we're going to share the value of time. So we can post like dance classes, for example. If I want to give dance classes to 5 children for a week, that's 5 hours of my life that I'm giving to other people. I can now get that value and redeem that value with other people who are also in this network. So it's kind of similar to cryptocurrency, but rather than transferring the value of money, transferring the value of time. By the way, communities like this do exist. Typically, it's communities who are less well off, and they do a lot of just free exchange, but it's really hard for them to track. So I actually met a couple of women in Toronto who, non-technical, they just heard about blockchain and figured this could be the perfect way to implement something that actually guarantees that people are getting the time back that they're giving to other people. So this is inspired by them. So in this case, what we do is we write the initial state of the blockchain, and then here I'm just giving an example offer of me giving this blockchain crash course for 1 hour. I guess there's like 50 of you in the room, so I guess it'd be like 50 hours, but no. So what we do is we set that up, and then we initialize Lotion with those beginning options, that beginning state. Then we create the transaction handler, which is that transaction protocol I talked about earlier today. So we create this so that we handle how operations get done on this board. Now this is very simple. So this is really just adding the chain adding the block to the chain. But in the future, we should make this more robust by checking if that has already been added, checking if the value is able to be transferred or not, things like that. Then we start Lotion with the board handler so that it knows to always use that to handle the board. And then we log the Genesis key. And the Genesis key comes from the origin of that block. So I'll run this before I get into the rest of it so you can see what's going on. Here we go. Again, it's just a JavaScript app, so it's just running it out of that one file. And it's giving us this community board here running on our local host. So I can choose a username. I'm going to choose something else. I'm going to say JS MobileConf. And then I can either offer a service or browse the ones that exist. So if I say browse, it's going to list all of the services that are currently available for claiming on the board. Let's offer something new. So I'm going to offer coffee brewing lessons. I have no idea. For 3 hours. Okay. Now if I browse again, that's been added to the chain. And I can go over to that link that it provided me, and I can see that it has indeed been added to the chain itself. So not only is it being added to sort of the local file, but it's actually being added to this entire state of the machine. So you can see here, /txs is all the transactions that have occurred now, and /state is all the state of the entire blockchain. So in this case, I, as JSMC, have only done one transaction, but the whole blockchain contains these transactions.
So does that mean that there were other nodes or whatever that validated that?
Yeah.
Are the nodes on your computer or actually?
Right now, this is on my computer. I've got it running locally. But it's set up so that you can publish it to a chain. Yeah, so anytime you develop a blockchain thing locally, you test it out on your local machine because ultimately it has to go to other people's nodes too. So it's not wise to test on an actual public network, especially if you're doing things that are not complete and can expose you to vulnerability. There's a lot of hackers in blockchain. It's a lot of people who like cryptography. OK, so I'm going to claim one of these now, and I'm going to claim number 1. So what it's publishing here is it's telling me that I'm claiming this offer. So let's go back in to the code and take a look at what that looks like. So in here, what we're doing is we're pretty much setting this chat dialog up, running through, and anytime that we want to actually claim that board, what we're doing is we're posting it to the board. We're posting it to the blockchain. So that is done down here when we post the offer. So in this case, it's really just an Axios call, which is super simple. This is the easiest framework that I've ever seen to make an update to a blockchain. What we're doing, we're just taking a new version of that state and sending it off and saying, OK, this is the state that I want you to add to your current record. And so all the nodes that are involved in making this decision will then run through that Tendermint consensus protocol and say, hey, does this make sense? Does this not make sense? Yes, it does, or no, it doesn't, can or can't be added. And then if we claim the offer, what we're doing here is we're picking the right one based on the ID. And we are posting this new offer, which includes claimed equals true. So if we go back to the sort of provisioning of this initial state here, where are we? I've set it up so that we've got a couple of values here. We've got the poster, which is the username of the person who's creating this. We've got the service, which is the name of the service, how many hours they're doing it for, and then whether or not it has been claimed yet. So of course, claimed defaults to false. But then once it has been claimed, then it can no longer be claimed once again. So if I go back over to the code here, or the demo here, we can see I've closed it down and I've restarted it. So now we'll see whether or not it's maintained that state, and it has, because it's still available on the blockchain. So whether or not we keep that app up and running, it's not pulling from our local current file. It's pulling from the network file, which is stored somewhere else right now on my machine. So now I'm going to choose Sage again, and I'm going to say browse. And oh, it doesn't look like it ended up claiming the offer, but now I'm going to see if I can claim this one here. And now it says coffee brewing lessons has been claimed. So if I run browse again, that should no longer be there. And we can see in the state now, we've added a new transaction to this chain where it's saying that coffee brewing lessons has actually been claimed. And if we look in the transactions, we can see it's been added there as well. Cool. So I think that we're out of time. Yeah, we've actually got another talk starting in 3 minutes. But I'll put this up here. This is where you can grab both of those projects. And also, you can find me on Twitter, online, or around the conference if you want to talk about it some more. Bed and Blockchain Start is really a tutorial. Lotion Pure Economy is an ongoing project. So if anyone is interested in contributing to blockchain and contributing or getting started with Lotion JS, please fork this. Please work with me on it, and let's build this out together. Cool. Thanks, everyone.